So here we are, we're going to take projectiles, but we're going to do some higher level ones where maybe you don't have as much information as you do on the others. So we're doing the same exact thing as before. We just might have to use multiple equations to get our answer. 20 degrees is our angle. 35 meters per second is our vector, so our resultant component of our velocity. How far away will he land? That is our range. As always, we draw that picture there. Okay, so now what do we need? Can we find the horizontal and vertical? We can. We can use all our SOHCAHTOA and triangle information. So same as before, Vx is equal to 35 times cosine of 20. And Vy is equal to 35 times sine of 20. Same process as before. Now we got to go look at that. We want to find the range. Do we have a range formula? We do. Distance in the x is equal to our range. It's the velocity in the x times the time. Do we have velocity in the x? We do. 35 times cosine of 20. Do we have a time? They did not give us a time this time. So we got to think more. My distance in the x is not going to help me with the time. Will my y help me with the time? Let me draw a picture. I have this picture going on. Okay. And if I have my velocity initial in the y is right here, 35 sine 20. What else do I know? I know gravity's pulling me down. Okay. So I have an acceleration. And what do I know right here? At my halfway point, I know I'm at my maximum height. Did they give me a height? They did not give me a height. That could have been one way for me to find the time, is using the height there. But I also know that this velocity final in the y is 0. So let me pull up what are all those equations that we had before. Velocity final equals velocity initial plus AT. Okay, so, and then what else do we have? Distance is equal to velocity initial times time plus 1/2 AT squared. And we had V final squared equals V initial squared plus 2AD. So all of these are going to be in the y right now because that's what I'm concerned with. So I'm just going to add some y's. That's all that matters. Every place that I see a component, I know I have to give the y component for it because I need to find something to do with the y to help me cancel out, and I'm trying to find time. So do I know my velocity final in the y? I do know that it's 0. Do I know my velocity initial? I do. It is that 35 times sine 20. Do I know my acceleration? I do. It's negative 9.8. The gravity's going in the opposite direction, so it's going to have a negative. And look at that. Time is the only thing left. This one does have a trick, so just don't take that and just run with it. Make sure you watch this whole way. So velocity final equals velocity initial plus AT. My velocity final is 0. My velocity initial 35 times sine of 20 plus a negative 9.8 times t. Okay, so 35 times sine of 20 gives me 11.97. Okay, plus a negative 9.8t. I'm going to move my 9.8 to the other side. And then I am going to then have 11.97 divided by 9.8. And that is going to give me a time of 1.22 seconds. Here's the trick. This is the time right here, 1.22 seconds. Is this for my full range? Remember, I wanted my full range. That's going from here to here. 1.22 is only halfway. The height happens at the halfway point. So I need to multiply that times 2 to get 2.44. So my time would then be 2.44. So really go carefully. So my range is going to be 2.44 times 35 times cosine 20. You might want to do it in that backwards arrangement just to make sure that you're not taking the cosine of 20 times 2.44. So watch your parentheses every time when you are working on that one. All right, so how about this one? Ski jump has an angle of 35 degrees. That's my theta. 47, that's my velocity. We want to hit a platform 5 meters high. That's my distance in my y. And 200 meters away. That's my distance in my x and my range. Absolutely draw that picture again to help you out. Draw in that platform 200 meters away, 5 meters high. Can I get my x and y velocities? Absolutely. Hopefully that's becoming second nature right now. 47 times cosine 35 is going to be the velocity in the x. 47 times sine of the theta, which is 35, is going to be my velocity in the y. So I have those two velocities there. What other formulas do I have? I have range. What is that range formula? Range is equal to velocity in the x times time. I know my range. It's 200. I know my velocity in the x. It's 47 times cosine of 35. So I just need to use that to find my time. Okay. So cosine 47 times cosine of 35 is 38. I'm going to take 38.5. 200 divided by 38.5 gives me a time of 5.19 seconds. That is my time for the range. So that is the whole time this time. How is that helping me? Because now I know the time that I'm going to need to take, and I can use that on my other equations. What other equations do I have? Distance in the y is velocity initial times time plus 1/2 at squared. So what do I know here for my distance in the y? Okay, I want it to be 5 because I want to hit that 5. Velocity initial, 47 sine 35 times time, 5.19 plus 1/2 acceleration. That's going the opposite direction, 9.8 times t squared, 5.19 squared. Okay. Now, when I do this problem, you're like, wait, there's no variables left. I am verifying that I would land at 5 meters. So if I get something else, I know that I'm not quite in the right place. 47 times sine of 35 in parentheses times 5.19 gives me 139.91 plus 1/2 times 9.8, negative 9.8 times 5.19 squared. And that gives me negative 131.99. So I'm going to subtract those two, and that's not looking promising, is it? 139.9. I have 7.9. My distance in my y is 7.9 meters. That means when I landed, I ended up at 7.9 meters. So if the platform is only like 1 inch wide, I would not make it because I'm still too far up and I would go over here. However, if they told me how wide the platform was, I could then extend my 200 meters. Maybe it goes to 205. Maybe I have a little extra time in that hand. So that is saying right now that yes, your answer on this would be for this one. It would not make that platform, but make sure that you're specific. But however, if the platform was wider, it might have a chance to come down. Okay. If your one is not hitting the platform, but trying to go underneath it, you have another statement. If yours is the one with the bullseye, you have another statement. You're trying to get to the center. So you might say, oh, it makes it to the bottom portion or whatever happens there. Just go slowly when you're working through it. Okay. And then we just go check the height. And that's it. Have a good day.